Welcome to the visual explainer of Salesforce AI Associate certification. In this video, we will go through the details of the certification exam and get started on AI fundamentals. In subsequent videos, we will get into more details and advanced topics related to this certification. In this certification, you are tested with 40 multiple-choice questions. 65% is the passing score for this exam. The exam costs $75 and you are provided 70 minutes to complete the exam. Here is a quick look at how the exam weighs different topics. 39% of the questions will be from the area ethical considerations of AI, 36% from data for AI, 17% from AI fundamentals, and the remaining 8% from AI capabilities in CRM. Let's start with AI fundamentals, which accounts for 17% of the exam. You will get approximately 6 to 7 questions in this topic. AI fundamentals covers 5 major areas: AI overview, AI for business, AI for customer service, Gen AI basics, and natural language processing basics. So, let's begin with a quick introduction to AI. Artificial intelligence refers to computer systems that can perform tasks typically requiring human intelligence. However, defining AI has become complex over time. On one hand, science fiction has portrayed AI as a threat, but the reality is much more nuanced. The current AI systems are designed to perform very specific tasks. And we can categorize them into 4 main types: numeric prediction, classification, robotic navigation, and natural language processing. Numeric prediction is generally used for predicting numbers like weather forecasts. Few instances where classification is used predominantly are to classify images, detect fraudulent transactions, and translate documents. Robotic navigation is used in autonomous vehicles and optimizing supply chain for industries. Natural language processing, popularly known as NLP, allows for translation, summaries, and conversational agents. NLP plays a huge part in generative AI. Okay, we covered a lot so far. But we are just getting started. If you need a break, hit pause and come back when you're ready. See you soon. Let's now review the role of machine learning and data in AI. AI transforms data into predictive models through machine learning. Machine learning is the process of using large amounts of data to train models, rather than hand-coding algorithms. Traditionally, programmers wrote step-by-step instructions to solve problems. But some tasks are too complex for that. That's where machine learning comes in. Machine learning lets computers learn from examples in data to recognize patterns and make predictions. Let's talk about the data now. We can classify data broadly into 2 types: structured and unstructured data. In simple terms, structured data is nothing but organized data with clear labels. A good example is a spreadsheet. Unstructured data is data with no predefined structure. A good example of unstructured data is images or text. The type of data, structured or unstructured, affects what machine learning techniques to be used. Awesome! We have covered a lot of ground so far. How are we doing? Take a break if you need to. If not, let's continue. There are 2 main types of machine learning: supervised learning and unsupervised learning. With supervised learning, the training data provides examples of correct inputs and outputs. The computer analyzes these to learn relationships and make accurate predictions on new examples. Unlike supervised learning, the key difference with unsupervised learning is that it finds hidden patterns in unlabeled data without examples of the right answer. Let's look at an example. A computer could be trained to estimate travel time to the store based on conditions like weather or traffic. The computer assigns initial weights to factors and adjusted them through trial and error until it could accurately predict travel times. The previous example created a predictive model that could then be tested on new real-world examples. If successful, the model is validated and can estimate future trip durations. To summarize, the key takeaway here is that machine learning transforms data into models that can solve problems and make intelligent predictions. We are in the final stretch here, and we will briefly touch upon neural network concepts. Neural networks are an important tool for training AI models. Traditional AI models have limitations because they can only consider the weight of individual inputs. Neural networks help address this by representing scenarios as nodes in a graph. Let's look at a milk run example. When predicting milk run times to the grocery outlet, factors like weather, time of day and day of week interact in complex ways. A basic AI model assigns one weight to rain, but we know the effect of rain depends on other conditions. Neural networks represent these scenarios as separate graphs connected by nodes. Each node, or scenario, gets its own bias value to more accurately reflect its unique effect. Combining these scenario graphs into a neural network with weights allows the model to consider scenarios separately and combine them into a final estimate. Real neural networks are much more complex. They add more nodes and hidden layers between inputs and outputs to find deeper patterns. This deep learning is how neural networks mimic the brain's ability to make complex connections. Neural networks operate as a black box. We can't explain the relevance of individual weights after extensive training. But by designing network architecture and letting the math optimize weights and biases, neural networks produce state-of-the-art results for tasks like image recognition, translation, and more. In summary, there are two key takeaways from neural networks. Neural networks are webs of node connections that use weights, biases and layers of complex math to model real-world systems in a way that surpasses traditional AI. Neural networks are essential for developing modern artificial intelligence. That's it. We are done with AI fundamentals. Our next chapter is AI for business. Catch you on the next video. Bye.